Hello students, today we are going to study the motion of an object in the vertical plane or how to use the equations of motion for the motion in the vertical plane. Now suppose an object with mass m is dropped from a particular height h from the ground now. Which are the forces which will act on this object as I shown here? One is the gravitational pull or the weight of the object m into g, where m is the mass of the object and g is the gravitational acceleration. Gravitational acceleration. It is also called as the gravitational field strength, and on the surface of the earth we will take it as a constant, which is about 9.8 meter per second square. Okay. Other forces which are acting on this object are the drag or the air resistance. Now, keep one thing in mind, that if the object is massive, we can neglect the air resistance. So, what will be the resultant force acting on this object? Now, since there is no opposing force in the opposite direction, so the resultant force will be just m into g, that is the weight of the object. And by Newton's second law, the resultant force is equal to m into a, which gives me a is equal to g, which is constant over the surface of the earth. And hence, since the acceleration is going to remain constant throughout the motion, the condition for the applications of SUAT equation is satisfied. That means we can apply the equation of motion for this particular situation. Now, another thing that you have to keep it in mind is that the sign conventions. Now, any vector that is pointing towards the right in the horizontal direction will be taken as a positive vector. Any vector that is pointing towards the left will be taken as negative direction, a negative vector. Similarly, any vector that is pointing vertically upwards will be taken as positive. Pointing vertically downward will be taken as negative. That means we will stick to the XY convention. Another thing is, suppose I am projecting an object upwards with a velocity of say 20 meters per second. Now, since this velocity is pointing upwards, I will take it as positive 20 meter per second by my sign convention. But as the object travels upwards, what will happen to the velocity? Velocity will go on decreasing, and at the maximum height, the velocity will become 0. At the maximum height, the velocity will become 0. That means as the object is traveling upwards, it is deaccelerating, and hence I will take A as negative 9.8, that is negative g meter per second square for vertically upward motion. And in a similar way, when the object will travel downwards from the maximum height downwards, its velocity will be negative. Its velocity will be negative, but as it is traveling down, it will accelerate, and hence I will take A as positive 9.8 meter per second square. That means whenever the object is traveling against the gravity, it will deaccelerate. So the acceleration is taken as negative 9.8 meter per second square. And when the object is traveling towards the gravity, it will accelerate. And hence the acceleration will be taken as positive 9.8 meter per second square. So keeping these basic things in mind, let us try out a problem here. An object is projected vertically upwards with a velocity of 12 meter per second. So find A, maximum height reached by the object, maximum height reached by the object, and second, the total time taken by the object to come back to the ground. So here, what things are given to you? The object is projected vertically upwards with a velocity of 12 meter per second. So, what is that? What is given to you? Initial velocity u is equal to 12 meter per second. And since the object is projected vertically upwards, that means this velocity will be in positive direction, so it is positive 12. Now, when the object will reach the maximum height, what will be the velocity of the object? Object will become stationary and then it will turn down. That means the final velocity will take it as 0 meters per second. So initial velocity u is 12 meter per second and the final velocity is 0 meter per second. So I will take v as 0 meter per second, and since the object is decelerating, A will be taken as negative 9.8 meter per second square. In this case, we have to find out the maximum height. That means we have to find out the displacement. Now, which is the relation that gives, or equation that gives the relationship between the displacement, initial velocity, final velocity, and acceleration. Obviously, v square is equal to u square plus 2as. Now, v square is 0 square, that is 0, u square, that is 12 square, plus 2 into a is negative 9.8 into h, the maximum height reached by the object. So h is 144, 12 square is 144 upon 2 into 9.8, and that comes out to be approximately 7.35 meters. That means the maximum height reached by the object is 7.35 meters. Now, let us come to part B here. Now, object is projected from some point on the ground. It goes to the maximum height. There it will become stationary. It will turn back and come to the ground again. So if we see the vertical direction, what will be the displacement? How do we define displacement? The shortest distance between the initial and final point. So vertically speaking, from wherever the object has started, it has come back to the same point, and hence vertically the displacement of the object is 0. Okay, because the shortest distance between initial and final point is 0. Initial velocity is 12 meters per second. A is negative 9.8, and you have to find out t. So which relation can be used here? Which equation can be used here? Which relates s with u, a and t? S is equal to ut plus half at square. S is 0, 12 t plus half into negative 9.8 into t square. So 0 is equal to 12t minus 4.9 t square. So 0 is equal to t into 12 minus 4.9 t. Take a t common. That gives you either t is equal to 0 or 12 minus 4.9 t is equal to 0, which is t is equal to 12 upon 4.9. Now 12 upon 4.9 is approximately 2.45 seconds. Now t is equal to 0 is the initial time when the motion is started. So the object takes how much time? 2.45 seconds to reach the ground. Reach back to the ground. Okay, so this is just one example I have taken with you today, but we will be doing more examples on this vertical motion, which the concepts are clear with you, and particularly the sign of the vectors and the sign of acceleration. As the object is moving upwards, the velocity will be positive, but object is decelerating, so acceleration will be negative. Okay, so just revise this. Okay, enjoy the day. Bye.